Hey, what is up guys? And today we'll be learning how to perform basic static analysis on a malware. So first let me start by introducing myself. My name is Mo. Now let's find out what basic static analysis is all about. So basic static analysis is basically examining of executable files without viewing their actual instructions. We can use it to confirm if a file is malicious, and it can provide information about its functionality as well. So basic static analysis is simple and quick to perform, but it can be really ineffective against sophisticated malware, and it might miss some of the important behaviors of the malware as well. So to perform basic static analysis, I've actually used 6 tools. So the first tool I've used is VirusTotal, and it's used for antivirus scanning. So what is VirusTotal? Is basically an online cloud antivirus scanner. So what it does is it compares users' uploaded files against known databases and AV engines in its cloud. And of course it determines if the uploaded file is malicious. And also it actually can scan for malicious URLs as well. You just have to upload it. So the second tool that I'll be using to unpack the malware is called PID. So PID can check if a malware is packed or is it unpacked, and also it can check the compiler of the malware, and of course it can also be used to unpack the malware. So next, the third tool that I'll be using is called WinMD5, and I'll be using it for malware fingerprinting. So what malware fingerprinting is basically to generate a hash value of the malware which is unique to that malware alone. So something important we can take note of from here is that the hash value is also used by antivirus software during file signature detection because it's only unique to the malware itself. So moving on, the fourth tool that I'll be using is called PEView to view some administrative information about the malware, things like its compilation date, which you will see later on. And the fifth tool that I'll be using is called Dependency Walker, which basically show us the imported dynamically linked libraries known as DLLs and its imported functions. So by looking at all that, we can actually it can give us an idea of the functionality of the malware, like what it does. And last but not least, I'll be using bintext for analysis of usable strings. So what does bintext do is it helps us decipher data into usable strings and can help us to uncover some host or network based indicators, things like IP addresses and file paths. So let's just jump straight into our VM and perform the analysis. So now you can see this is the malware, and this is the basic static analysis file which has all the tools that we'll be using it. So first we have to upload this malware to VirusTotal, and I've already done it, and let's look at the results. So from here we can see that about 51 out of 65 antivirus engines in VirusTotal's cloud has detected it as malicious. And what it most likely to be, we can see that it is most likely to be a keylogger. You can see it's keylogger here, and keylogger. So it's most likely to be a keylogger. So next, let's check if the malware is packed. So we'll be using this tool, PID, which I've mentioned. Let's fire it up. So we can actually simply just drag and drop the malware, and from the EP section you can see it's UPX1. UPX is basically stands for Universal Packer Executable. So it actually pack executable files, and you can see the version of UPX that it is packed in. So since it's packed, we have to unpack it, and we can use PID to do that like I've mentioned. So we just go to plugins, and you can see Unpacker for UPX. So you just click it, and there you go, it's successful. And this unpacked version of the malware is stored in the PID file as well. So we just simply drag and drop into our desktop because we'll be using it later on. And now drag and drop the unpacked malware into PID, and there you go. You can see under EP section it says unpacked, and it's actually compiled or maybe written using Microsoft Visual C++ 6.0. So that's it for carrying out, whether seeing if the malware is packed and unpacking the malware. Now let's carry out malware fingerprinting. So we are going to use WinMD5. So first, let's just drag and drop the packed malware. You can see the hash and the size of the packed malware. Now let's drag and drop the unpacked one. So you can see the hashes are totally different, and something interesting is that the packed malware is much smaller compared to the unpacked one. And that's it for malware fingerprinting. Now let's take a look at the administrative information about the malware. So we're gonna use PEView for it. So fire up PEView. So first, let's check for the unpacked one. So we can just drag and drop it, and under image file header you can see the compilation date, and it actually said it's in 2031. And what we can assume from here is that the malware is probably compiled in a computer which with its date modified, because it's only 2019 right now, as you can see from our computer's calendar. So let's find out the actual compilation date using maybe packed malware, whoever has it. So we just drag and drop the packed malware, and under image file header you can see that it actually compiled in 2003 in the 5th month and on 14. So that's it for viewing the administrative files. So now let's take a look at some DLLs and functions that it has imported. So let's look at dependency walker. Simply just drag and drop the unpacked one. So from here, let's just minimize it. So you can see this is 4 main DLL. So first DLL, which is ADVAPI32. So, and we can see the functions that it has imported. And as you can see, it's basically things like rec delete value, rec open key, rec set value, which is most likely to be manipulating the registry values and registry files in the system. So let's expand it and look for some interesting stuff. And looking at SSPI CLI DLL, we can actually see it's get username again, and log on user. So what does get username does is basically gets the username of the current login user, and log on user is a function which is used to basically attempt to log in as a current user. So we can see it, basically the malware might be trying to impersonate the current user. So next, let's check out the main kernel32 DLL. So you can see it's copy file, create process, and furthermore you can see things like get command line, get current process. So what it's basically doing is trying to manipulate all the current processes, and also it's trying to create a process, it's trying to copy a file, and last but not least, it's trying to write in the data into a file, which we might be able to find out later. So under user32, there's nothing much, and under WS232DLL, you can see some important functions again. So first thing, connect is to make a connection to a IP address, and inet address is basically converting this string to a TCP/IP IP address. And you can see WSA socket. So what it mostly trying to do is basically to connect to an IP address through a socket. So now that we actually kind of figure out what this malware is trying to do, maybe we can find out more using bintext and look at its usable strings. So let's check it out. bin tag, simply just drag and drop the unpacked one. So now from the result of the bin tags, you can actually see a lot of the same functions which we have seen using dependency walker. So you can see things like create process and like connect, inet address, socket, there's a rec open key, set value, delete. So now let's look for some a little more interesting strings. And here we go. So from here we can see three interesting things like get last active pop-up, get active window, and message box A. So from this three we can roughly assume that the malware is trying to get the last pop-up window and use that window to display a message. And also we can see a user32.dll in a lowercase, which is most likely created by the malware because using dependency walker we actually don't see any lowercase DLLs at all. And the most interesting of all, we can see it's 10.24.9.100, which is most likely to be the IP address that the malware is making a network connection to. And you can see a file that might be being created, an executable file, most likely to be created at this path. And you can see a Microsoft system log file, and they boot up the malware boot up command prompt, which most likely means that it's going to edit the Microsoft system log, most likely. And so from this result of the basic analysis, we can actually see these followings: is that the malware is most likely to be a keylogger from VirusTotal, we can see that, and it's packed using UPX, which we have seen from PID, and it's written using C++ language, most likely, and we have seen it again in PID. So it actually is compiled at in 2003 in the month of May at the date of 14. And also using dependency walkers, we can roughly take a guess that the malware is trying to manipulate registry values and the process. It attempts to log in as the current user and make a network connection to this address, which we have seen in the bin tags. The strings show us that it's this IP address 10.24.9.100. So also it created a syslog.exe file at this file path, and these are the results we can see from basic static analysis. And last but not least, thank you very much for watching this video. Thank you very much.